My name is Kurt Takara, and our poster is on next generation Power CDC verification and the lessons we've learned. We're pretty excited that our advanced CDC analysis verification is addressing some of the new challenges in low power design. And what we're seeing is that with today's RTL design, there's some design information contained in the UPF files. And this information can be used with the RTL to verify designs for any CDC issues. So some of what we're seeing is that typically design teams are looking at having the isolation cells modeled in RTL and verifying those paths for CDC analysis. But with some of the new advanced low power designs, we're seeing some additional challenges. So some of what we're seeing is the fact that now synchronous clocks across two different voltage domains are now being modeled asynchronously in silicon. So what we need to do these days is to make sure that these paths are considered asynchronous crossings, and designers are going to want to make sure that they have synchronizers on the receive side of these paths across two different voltage domains. Additionally, what we're seeing is that isolation cells can also introduce crossings. So not only could they possibly introduce crossings from the enables, but also the fact that the isolation cells could add combinational logic that could compromise the integrity of the synchronizer. So today's CDC verification easily addresses the isolation cells, but some of the advanced capabilities now require that we address not just the isolation cells, but also the retention and the voltage domain crossings. So what we're doing in advanced low power CDC verification is to, number one, do a structural verification to ensure that the structures CDC structures are good. Additionally, we're looking at some dynamic CDC verification to make sure the protocols ensure that there's no data loss or data corruption on these paths. And finally, we want to make sure that the voltage domains are being verified. So these voltage domain crossings should have synchronizers on these paths. Some of the results we're looking at is the fact that even some of these single CPU or so some of these CPU designs have one clock, but with voltage domains, we now see 6 asynchronous clock domains. So that means there's some additional CDC paths that need to be verified on even single clock CPU designs. So the UPF information adds the power control logic to the RTL, and we support UPF 1 as well as UPF 2.0 and 2.1. The UPF will not only give us the information about the isolation cells and the retention cells, but it also gives us information about the power domains and which power domains are on different voltages. In summary, we're very excited about our advanced low power CDC verification and the advanced techniques that we're using to verify both isolation and retention cells as well as power domains that are on different voltages.